Hey everyone, thanks for coming. And yeah, just before I start the talk, this is a disclaimer. So this is not a talk in which we'll be going in depth about generative AI. I think you've had a lot of talks today that have gone in with ChatGPT and what they're about. So this talk is about the real problems that we faced while trying to do a few things and what solutions we came up with. So it's a personal story, it's a personal problem, and we are going to be going into what we used and how we solved these very real problems. Okay. Now, again, please settle down. It's cool. So who am I? So I am Dr. Sidharth Ramesh. I'm a doctor trained in India, and I now run a company called MedBlocks. So my story began here. So I was in med school. Both my parents are doctors. So in India, that's the default path you take. You also study to become a doctor. And that's me over there. And what happened was that I had to wake up almost like right after finishing med school, you had to practice for about a year. So during this period, I had to wake up at 5 a.m. every day to go to the hospital to open an application, a lab application, and I had to copy records from this application and then put it in another application. This took like around 5 minutes for a patient, but we had like 80 patients. So overall, like it would take me up till like 10 a.m., like 5 a.m. to around 10 a.m. So I'm just like doing this and checking other records and so on until the visiting doctor, the person who's coming in for the main rounds, they come in. And I got really tired of this. So I knew how to program even while I was in, like as a kid, I knew how to program. So I wrote a script that would automate this for me. So I wrote a screen scraper that would like automatically open this application up and it'll copy this, and things worked. But I could only run it on the computer which had these applications installed. So I installed them in that system. And the next thing I know, there are 40 people waiting after me in a queue in that particular hospital ward, waiting to use the same script that I wrote to automate things for their applications. And it didn't make sense, right? So I tried to contact these EHR vendors. I tried to understand, like, hey, is there can we integrate this script somehow? Can we get the functionality that we want somehow? We are ready to program. We are ready to do anything that we want. But then it was just a clear, we don't care attitude from the EHR vendors. Like it's not in their best interest. They don't really care. Like it doesn't drive their business goals. And they were not interested. So for me, the journey has always been, can we rebuild the whole IT infrastructure for healthcare? Can we build the whole EHR as just apps on top of standard APIs? Right? So this has always resonated with me, and this idea of having one standard health APIs platform, whatever this is made of, and then being able to just plug and play these apps and then have everything work to then form the health IT infrastructure. So this has always been the goal that I wanted to go after. And we at MedBlocks, we've been trying to build this health API platform. And one thing led to another, and our product, we are still working on it, but we have to consult and contract with other people to make enough money for us to support the product. So we started working with an insurance company. So this was a project that we were working on. And what happened was that this insurance company was receiving documents from multiple hospitals. And these documents are all they're completely, you wouldn't believe the kind of documents they send. It could be a PDF of a lab report. It could be an image of a handwritten prescription. It could be an image of their granddaughter. It could be anything, and we get it on to the insurance company. And we somehow had to make sense of all of this data. And the insurance company was doing some analytics on this data to make adjudication decisions, and they're just doing their own stuff. But they also had to export this data out. So they had a few partners in India and a few partners in the US. So they had to export this data that we then collect out into the Indian ABDM FHIR profiles, the resources for that, and the US core FHIR profiles. They also had other partners who had like other proprietary formats. So now you may ask, how exactly did we do this conversion? How did we like get completely unstructured data and move it into the data platform in a usable way on which you can run analytics? You may think this talk is on Gen AI, but surprise, we had a team of humans who manually looked at all of these documents, and they were inputting in a program that we built each and every field. Okay, so like from copying lab reports from one application, I had almost come full cycle to having my software be used for inputting data. But I think this is a good starting point, because this is a real problem, this is a real solution. We had people who are able to do this, and they were doing it relatively well. These are all medical coders, and they were trained to do this particular task. So now, the goal that we had and the problem that we exactly had here was that we wanted forms that can capture data from any unstructured document, okay? And we wanted, we had a few constraints to work around. So data capture is expensive, right? Like every time this document goes and sits in front of a digitizer, we are using up their time and resources. So we want to ideally do this only once. We want to allow the hospitals from which these data points are coming from to define new structures and new, like, tell us what it is that you're capturing, right? We want to tell them, hey, tell me if it's a prescription record, what are the different data points that you have here, in a very low code, like minimal configuration kind of a way, so that the new data is also captured with the same amount of ease and complexity, right? It should allow the capture of the correct structure of the incoming document. So we wanted to maintain the semantics of the document. So we wanted to have, for example, if it's a prescription record, then it needs to have a prescription document, and then it needs to have the medication request, it needs to have the patient demographics. All of this needs to be maintained in the document that we are capturing. And this is a main one. It may seem like it's insignificant, but hear me out. So it should support as many analytics use cases as possible. So the main reason for capturing this data for the insurance company was adjudication. And they wanted to capture as many data points as practically possible. But then they came up with these new use cases now and then. So they wanted to capture another data point, and they'll capture this data point. So they usually called us, and they're like, hey, we want to add this other data point in our form. And guess what we had to do? We had to send these documents again back to the digitizers so that they are able to work on it again. So that's like really expensive. So we wanted to capture as many data points as practically possible on the first pass, so that you are not sending this back and forth to the digitizers and capturing this data again and again. And again, like, we should map it to multiple FHIR profiles with as minimal effort as possible, and the proprietary data format. So this was just the constraints that we had. Now, the options were, of course, we could just define our custom schema definitions in our own database and start with that. But then I didn't want to give up on my vision and goal just yet, just for this one project. I still wanted to build that standard-based EHR on top of which you can run these applications. And this is a healthcare scenario. This is a purely healthcare-based problem. So I didn't want to create my own proprietary EHR to do this. So FHIR questionnaires were an option. So I think a lot of talks on FHIR questionnaires so far. So the problem we had, though, was that you still had to manually define the data points, and then you had to manually define the mapping to the structured resources and the structured data points. So this amount of effort into each and every questionnaire was not practical. The other option was we could profile resources. We could create resources based on some profiles and get that. But again, this meant that the analytics use cases that our insurance company was looking for may not even be met with the profile definitions of both the Indian as well as the US core. So we initially started off with just putting together these profiles and then having our own internal profile that had all the common data points. But then the insurance company wanted to do more. They wanted more data points, and they wanted to analyze more data points in the document that were not present in the FHIR resource. And again, FHIR compositions is the other option, right? Like, because you want to capture the document to begin with. But again, even if we do this, and even if we semantically are able to capture the structure of the document, you still had the problem with the resources not having enough data points. So I just want to raise our hands. How many of you have had this question in the past? Like, how do I model this in FHIR? I have no idea how to model this in FHIR. Okay, that's majority of the room. Okay. So this is the problem that we were contending with, which is how do we model this in FHIR? We are getting like truckload of documents which had X, Y, Z, and anything that the healthcare enterprise might have. And FHIR resources are like this transmission mechanism that we have, which is only sending documents and which is only sending resources that make sense in an exchange context, right? And what we were actually trying to do here is model the domain, right? Like we were trying to get to these domain models. And I thought, okay, as an extension of FHIR and as an extension of what we've done with FHIR with interop, it should be possible to also model the domain in FHIR. And we see a lot of people doing this. The talk by Google where they are starting to store everything natively as FHIR. Health Samurai is doing this. And a lot of other people are trying to model data primarily in FHIR, right? But is this really, does it make sense? So I asked Graham. A lot of people are using FHIR natively for storage. And I know you are against this, and I've seen a lot of your other talks where you've explicitly stated that FHIR for storage may not be such a good idea. But we are again seeing this pattern where people are separating the apps from the data, and then they have this data platform, and they build their apps on top of the data platform. What are your opinions on this kind of usage of FHIR?
It's not that I think it's a bad idea. What I think is, we designed FHIR, we designed it for interop. And so it's denormalized with boundaries that are chosen by considerable community discussion to represent resilient, robust units of exchange. And those units of exchange are not the units that you would choose as storage units inside your system.
Okay, so we have it. So it's not meant for the domain model, right? So what is? So what is meant for the domain model? So FHIR is clearly meant as an interop standard between different systems in a black box. So it's meant as a facade on top of existing systems. So what is the answer to the domain models, right? So I want to give you a historical context of FHIR and how this came to be and what really happened, right? And this is, again, a paper by Josh Mendel, where we go over, like, in 2011, after HL7 realized that V3 was not really working, they launched this Fresh Look initiative. And two key initiatives were actually of mention. So one was the Clinical Information Modeling Initiative, or the CIMI, by Stan Huff, which worked closely on openEHR archetypes, and Resources for Health, designed and published by Graham Grieve. And we are all sitting together today in FHIR DevDays, right? We are not sitting in CIMI DevDays, or we are not sitting in that. So we know which standard won and which format won out. But then I think there is benefit in going back and understanding, okay, what is this? What was this openEHR archetypes and openEHR, if you see that? So what openEHR is not, right? I want to clear all your misconceptions of what you might have. So openEHR is not an open source implementation of an EHR. So you have OpenMRS, you have openEMR. These are all open source implementations. OpenEHR is not an open source implementation. It's a standard just like FHIR. OpenEHR is not an openEHR on the internet that anyone can access. So a lot of people just look at the name and they assume this is what it is. It's not, right? So what openEHR is? openEHR, just like FHIR is pronounced FHIR, openEHR is pronounced openEHR, usually openEHR. And openEHR is an open standard for storing, querying, and sharing electronic health records. It is language agnostic and it is database agnostic. And it answers the question, what do you use, which standard do you use to model this, the domain model? And if you look at around the world, what's happening, it's not like openEHR is just like this thing sitting on the side, it's a niche thing. No, like multiple countries, multiple city-wide implementations or region-wide implementations have their whole EHR system and their whole IT infrastructure based on openEHR. So Catalonia went with their whole country's digital adoption based on openEHR. The whole city of Moscow, thousands of practices in the NHS, the whole country of Sweden. And there is already precedence of openEHR around the world, and people are using it. Now, how does it exactly differ from FHIR, and what are the three main differences? So FHIR data modeling is usually use case based. And this is also the great thing about FHIR. It's that it gets things done immediately. And you're able to model what you want for your specific use case. And it follows this 80-20 principle and doesn't go into the majority of the data types because it just follows what is useful for a lot of people. openEHR archetypes, in contrast, are global and maximal with a focus on thoroughness. So if we take blood pressure, or if we take Glasgow Coma Scale, or if we take heart rate, what are all the different things that can be captured in this particular data model? Let's capture all of them internationally and let's agree on them. And FHIR was built for exchange and healthcare data, and it was done for interoperability, and it was this black box interoperability. openEHR was built for storage of clinical data and intraoperability from the scratch. It was meant as this platform for things to run within a system. So the FHIR community is mostly developers and people who code, whereas the openEHR community is mostly clinicians and people who model information. Not to say that it's not the other way around. There are people who code in the openEHR community, and there are clinical information modelers in the FHIR community, but it's just the proportion of people as a community, right? So how exactly does openEHR work? So you have an openEHR server, and you have REST APIs. It's exactly like how a FHIR server would work. And instead of just slinging resources immediately and starting to store resources, you need to first do one small step, and I'll show you how simple it is. You need to take these things called archetypes, and you need to put them together into these things called templates. And then you post this thing called a template, and it's just like, it's an XML blob, it could be a JSON blob. You put this thing called a template in the server. And this is, for example, what an archetype looks like. So this is done after years and years of rigorous activity on this, the international modeling community, and they come up with, for example, let's say pulse and heartbeat. What are all the different things that can be captured under pulse or heart rate? It's simple. You may just say it's rate, it's just the heart rate. But no, it actually makes sense to capture things like the regularity of the pulse. If the regularity is irregular, is it irregularly irregular or regularly irregular? Try saying that. So it makes sense to capture all of these at an international level, and then at the local downstream level, while you are taking these data points and then putting it for your own practical purposes, instead of extending this like how FHIR profiles do, like there is a base which doesn't define anything, and you extend on top of that, you cut down the things that you don't want. So here, for example, we have blood pressure here. You put this in a template where you can have multiple other archetypes, and then you cut down the data points that you don't want. So for example, you have systolic and diastolic. You don't care about mean arterial pressure, pulse pressure, clinical interpretation. You just cut these things out. FHIR does not have a place for this except extensions, and except each profile will come up with its own way of defining the same thing. And we've seen this happen with the profile proliferation on FHIR. And then you can easily just like post an instance of this data, like composition is just an instance of a template. It's again like JSON. You just post this, you use a data endpoint. And most of the time, there is very rich tooling in the openEHR community to develop forms from these templates. So you can automatically generate forms, just like the questionnaires in FHIR. And this is what our team was already using to enter this data. Now, the cool thing here is that although we have created this template and we have automatic forms built out, you can also query the openEHR server, just like you would a SQL server. So it has another definition called AQL, which stands for Archetype Query Language, which it looks kind of like this. And you can use this not only to query, for example, oh, I need, give me all the systolic and diastolic for this patient, but you can also tell it, I want it under this template, or I want it under this particular form. So that allows you to almost compose really like complex queries. And for example, this was enough for our data platform analytics needs. And we also like, you can easily like render widgets and graphs by just providing an AQL query. And yeah, we're seeing this in FHIR as well. Like, so we have SQL on FHIR and we have all of this, but this has all of this from the start, and it was built in with this notion of you use this as the primary data storage mechanism. Now, I could quickly just show you, like go to the CKM, for example. Are you able to see my screen? Okay, hold up. Should I exit the presentation to, yeah, this is okay? So for example, if you go under observation, and let's take a look at something, right, like UPGAR score, for example. If you take a look at, okay, UPGAR score was defined, it's to be used by this, it's been worked on by almost 20 people and translations by in these many different languages. And if we start looking at the data type here, there is almost everything, like respiratory effort, with the SNOMED CT and allowing codes for each and every data point. I can't say this about a FHIR profile because we don't have an international FHIR profile that defines UPGAR score. And if I take, for example, let's say body segment area, it's in version V1, and it's not just like one or two, it's like hundreds, and it's close to 1,000 right now. There are thousands of such archetypes, and we'll see why this makes more sense later on. But these archetypes, these data models are already defined. It's available, it's open. Anyone can go there, download the definition, and use it in their own systems. And you know, it has all of these different data points and data definitions done, and this is more than 20 years of effort of the clinical modeling community that actually has made all of this possible. And if we go to a tool, sign me out, but let me see if this works. So all you need to do to build a template, so let me quickly go here. So for example, I create a test template, and I tell that, okay, I'm interested in capturing blood pressure, and I'm interested in capturing the heartbeat, okay? And under this, you can cancel out the elements that don't make sense, and you can just like enable, for example, systolic and diastolic. Maybe I'm interested in the position, but you also have this already populated enum, like standing, sitting, reclining, and so on. And let's go to cuff size. Probably not interested at this point. But let's go to pulse and heartbeat. Just enable, for example, the rate. I'm going to cancel everything out, just enable the rate and maybe the regularity. And if you see the irregularity type, it has this modeled already. There is character, there is like all of these things that you would model. And after you're done, all you need to do is export this into a file, and you get this nice looking definition. Sorry that VS Code is taking a bit of time to load up, but you get a definition of everything that you need to know about this particular thing. So OPT stands for operational template, and you just upload this whole thing into an openEHR based system. So for example, here I have our platform, and all you need is you can upload this and you can start capturing this data immediately. So you have like systolic, diastolic, and rate, and I can submit this, and it creates an instance, and this is the graphs that you saw. So let's continue. What if your use case or your particular data modeling needs are not already in the CKM? There are thousands of archetypes, but then what if it's not already there? No problem. You can create your own archetype. It's a first-class citizen of this whole ecosystem. You can create your own archetype. And not only can you just create it in a matter of minutes, you can also submit it onto the International Clinical Knowledge Manager for review and adding it into the main archetype repository. So this process is built into openEHR, whereas in FHIR it would have to be either a community working group meeting or the whole process is completely different. Now, we were happy with this. So we used openEHR for our data platform, and we were converting the data from openEHR to FHIR for the Indian ABDM profile and the US score. So your question here might be, again, like we didn't go with any of these options. We went with openEHR templates and compositions. And your question here may be, how did you map from openEHR to FHIR? Well, there is tooling around that. And there is a spec here that you can just define a YAML file, and it maps from an openEHR archetype to any FHIR profile. And for the more popular profiles like US score, these mappings were already available. And even if we had to map this to these proprietary formats, the CKM and the clinical model was already so richly populated with all of these codes. So for example, it tells you exactly which line code it is, exactly which SNOMED code it is. It was just a matter of like finding which data field points to which data field. There was no more brainstorming needed on, okay, which values do these map to and so on. And then this happened. Right, so ChatGPT and the whole LLM race began, and what do you think this is? Yep, you're right. ChatGPT gets this right too. And with the introduction of image-based LLMs, you're able to like segment any document. You're able to just like cut documents into different pieces. And I'm not going to go into the details of this, but ChatGPT today has something called function calling. How many of you have tested out or tried out function calling in some way? All right, the minority. Okay, so for those of you who are not aware of OpenAI function calling, you give it the usual messages, but you can define a set of functions that it can call, and those functions need to have a JSON schema. And ChatGPT and OpenAI guarantees that the response of the LLM would comply with this JSON schema. Okay, so it's almost like, and you need to provide a good description in the JSON schema itself for the model to understand what this data structure is. So we are spending a lot of money on this. We are spending, like, each digitizer costed us a fortune. We are doing this at scale. Just imagine what this would look like. So it was just a problem of, can you take a document, all you needed is the JSON schema, right? All you needed is a really good JSON schema to get the structured data out. But the problem is you need to generate this JSON schema for the model to perform really well. So how do you generate this JSON schema? So obviously we can define a custom JSON schema for each and every use case. You could derive it from FHIR resources. You could derive it from FHIR questionnaires. But again, we had other problems with this. We had, like, obvious problems. And in fact, sometimes my team tells me that it's actually easier to map from openEHR to different FHIR profiles than it is to map from FHIR to FHIR profiles. So we obviously chose openEHR templates, but I want to just give you a view of what that enabled us to do and what that gave us. So openEHR already came with these extremely good definitions of what was available in a data model. So for example, if you take body mass index, not only does it tell you in the use, like, when to use this, it tells you the formula to calculate it, it tells you exactly when not to use it, it tells you the validation for what is the range of body mass index, it tells you all the units that can be used with this. When we compare it to an equivalent or a mature FHIR profile, for example, the US score, it is more technical about like, okay, this is the profile. There is absolutely no definition here about what body mass index is or what the formula for this should be. And here again, as you see here, the value quantity here is not really validated. So there is no way for us to generate a JSON schema automatically to just like represent, okay, body mass index cannot exceed this limit, right? So for us, it was almost like the prompting and the JSON schema that we were able to generate with openEHR templates felt like it was prompting on steroids. Whereas with what we had here, it was like, yeah, it works sometimes. And it's just a comparison of the data models and the maturity of the openEHR data models and how it compares if we compare it to FHIR. So for example, in observation, like you have a few clinical observation resources in FHIR, like condition, observation, and so on. But openEHR models all of these as proper entities, like as we've seen in the CKM before. If we go down under here, there's like respiratory rate, pulse oximetry, like story history, and testicular volume. These are not even, it's not that, I don't want to say that the FHIR community has not thought about this. I'm pretty sure people are working hard independently in their own organizations trying to model all of this. But it's not available in a way that's just like, hey, if you want to measure testicular volume, just use this. So that's not available right now. And it's just a quick demo. I'm not quite, the AI part is not the impressive bit here. I think it's a trivial problem to solve. And I think with the maturity of large language models, this will only get easier and easier for anyone to do. It's the data definitions, it's the JSON schema, it's the prompting, it's the what do you use as the data models in your database to begin with. These are the tough questions and the tough problems that we'll all have to face. So yeah, this is a cool demo, and like we show it, and yes, this is cool. But that's not the point of this talk. The point is like, are we, this is what we are doing. Are we missing something by just using FHIR questionnaires and using FHIR to store data? So this is what we are using right now. At least from personal experience, we are very happy with it. And you can contact me at MedBlocks. I have a lot of YouTube videos, including ones on FHIR. Just reach out on LinkedIn as well. I know a lot of you might be uncomfortable after this talk, but this is an important discussion in my opinion. And we do a lot of community work around FHIR, so including like the free videos on YouTube. We conduct webinars, and this one you can join if you want to build along on Epic. But I have another session tomorrow at the Heritage Gallery at 2:30. And we're talking about FHIR profiles and how they compare with openEHR templates. Now recently there has been a press release by both HL7 and the openEHR community saying that they will put forces together and they'll join and they'll make something work, but we don't know what that something is. So for me, it's about making the community more aware that, okay, there is something called openEHR and it does certain things really well, and it has worked for us in this particular use case. And yeah, let's start with the questions.
Thank you so much, Sidharth. I don't see any pitchforks yet, but maybe some questions?
What is the underlying data structure? Is it a graph, or are you defining a graph and then you're mapping that to a document store or SQL?
So that's completely based on the implementer. So the openEHR spec is completely like agnostic to whatever database technology use. We've had implementations on Postgres, on Cassandra, on MongoDB, on all these technologies. What it defines is a set of REST APIs and data models that you can like package and make your REST APIs function on top of. So that's all that openEHR itself defines, and you have these data models that you can take and use from the CKM. But yeah, the database implementation is up to that specific implementer. There are open source servers out there, though. There are open source openEHR servers, like EHR Base, which is by a German company. They are Postgres based on Postgres, yes.
Yeah, interesting talk. And I think one thing that I have been thinking through, or trying to think through, since the last Connectathon working group meeting, there was an announcement that HL7 and openEHR will be working together to collaborate on improving interoperability. But since you mentioned that openEHR or openEHR has that capability of modeling data better than FHIR, although FHIR, I think it started with a different purpose. Now I think it's coming together. So I don't know if you have thought through this. I understand this way of modeling everything in openEHR and then connecting with another system using a FHIR paradigm. But is there a way to use both of them together in a single system?
Yeah, it's a good question. And in fact, we do, because openEHR does not allow you to represent anything apart from clinical data. So you can't represent things like patient, you can't represent practitioner, you can't represent encounter, you can't represent organization. It's purely clinical data. So we also have a FHIR server running alongside, but we just don't model any of we don't store any observation natively in FHIR. We use openEHR and then map it out based on the profiles to the FHIR resources. So that makes sense for us, at least.
Have you seen any graph database implementations of the spec?
So by graph, you mean like RDF-based implementations or something like Sparkle?
Like Neo4j or...
Right. Not yet, not in the wild, no. Are there any FHIR servers based on graph databases?
It seems natural to me.
Yeah.
Yeah, I know there's been a lot of discussion on GraphQL, and if you're an app developer, you want a GraphQL API. If you're a server developer, you don't want to build it because it's...
That was my next question I forgot to ask. GraphQL seems like a natural extension of this spec.
Right. GraphQL to me is just a API level concern, so it could be through REST, it could be through GraphQL. For me, it's more about the underlying data models. Maybe there might be a more easier way to query the same using GraphQL. But for example, if you take FHIR, FHIR with, like, let's say, bulk enabled, and you are able to do different searches in a same FHIR bulk API, that kind of does what GraphQL does. And you're able to do all of these things with FHIR REST. So it kind of comes down to that. So GraphQL to me is more of like a superficial level abstraction that it could be implemented on top. It's not a huge deal. Yeah.
So maybe a question for me, Sidharth. On the openEHR, like I'm way less familiar with openEHR than you are. So, but openEHR starts more from the perspective. FHIR is kind of, for me, very pragmatic. Like it starts with very loose data model, and you can narrow it down for all kind of specific use cases.
Yep.
Kind of assuming that we know that many healthcare practitioners don't even agree with each other across hospitals or jurisdictions how to store something. But openEHR seems to become more from the concept like, no, we work out together, sit long enough in a room that we all agree on how to do the data model. Is that possible? Is it like, does everyone agree how you modeled blood pressure, for example, or are there people who don't agree? Like, how does that work?
Got it. So yeah, I think this boils down to the basic philosophical differences between openEHR and FHIR. And I tend to agree that healthcare and the human body is universal. And the way that we treat patients around the world tend to be around the same principles. And they tend to be, regardless of whether your insurance reimburses you or you pay it out of pocket in India, the human body at the end of the day is the same. And the doctor who has looked up and read research on the same thinks in the same way. And they model that domain in the same way. So for me, as healthcare matures and goes more and more into like systematic treatment of a particular disease, it will become more and more standardized. And you're not going to have these like just use case specific data modeling needs. And if everyone can agree on these global data models, it benefits everyone else, right? Like you just have to define these data models once. And you can write all downstream artifacts, including clinical decision support, forms, everything is derived on top of these. Otherwise, you're just like left thinking about how to define blood pressure for the 40th time.
Nice, nice. Is there a question here?
Good question, by the way.
And are there any specific areas that are in openEHR completely not defined yet? Like, are we missing ophthalmologists or whatever? Or?
So I would definitely agree that FHIR is more mature because of the adoption and the support it's gotten from the community. So especially like right after Apple adopted it and like the ONC went after it, there's been a lot of tooling and things around FHIR. But we're seeing that change. Like for example, there is no hosted openEHR server today that you can take on any cloud provider like AWS, Google, or Microsoft. But Microsoft and AWS recently announced that they are collaborating with openEHR. And we don't know what this will look like, how much time it will take, but yeah, it's to be seen. It's not as mature as FHIR right now.
I'll just keep going if not. Okay, yeah.
Thanks. Hi. Thanks for the presentation and starting this discussion. In Germany, we're using FHIR a lot for health research, so we're using a lot of resources from research study or evidence-based medicine. And you said it's mostly clinical data. Is it going to open up for this type of content as well?
Of course. I actually think there is a very good use case to be made, especially in research. So the mapping engine that I was talking about, they also have mappers to OMOP. So automatic openEHR archetypes to OMOP translations. So what you get as a researcher is that you get to define these data models once and use it for primary capture of data in the clinic, in the EHR, and secondary use. There are no two different data models that you have to map with. And you can run analytics on top of openEHR. It's one single repository, you get everything, and it's de-identified by default. So there is no patient information in there, so it's de-identified by default. So a lot of people do analytics directly on top of openEHR repositories. And yeah, they talk in FHIR, they receive data in FHIR sometimes, but they use it as their main source of truth.
So really good talk. And I'm not sure if I'm seeing there's any sort of conflict here. Tell me if I'm wrong in my thinking. It sounds like, say we have a perfect world where everybody's using FHIR for exchange in a standardized, way. In theory, it sounds like everything message that could be sent that way could populate a database or whatever data repository based on openEHR. openEHR probably covers more things because there's a lot of typically not, I assume sometimes FHIR doesn't have things because they're just never structured or something like that. And openEHR does because it's biology, right? Which is what you're getting at. So, it seems like that's the point. It goes to what Graham was saying, if I got it right, he's basically saying, the primary use case is the discrete exchange.
Yep.
Which it's exquisite, it's extremely well designed for. So
yep.
I guess I don't see this as a problem. I kind of see this more as an opportunity.
Understood.
But that's just a perspective. But
I'll tell you, so the problem here, at least for me personally, this is my opinion, is that if you have a high definition television, but your internet is just slow enough that it can stream standard definition, then what's the use of a high definition TV? So it's like we are capturing all of this data with all the rich semantics and the data models in openEHR in primary care. When we are translating it to the FHIR resources and when we are sending it out for so-called interop, we are sending like a subset of all of the data that we have. So for me, that is like, I'm like, I have all this data. Why don't you also receive all this data? And they're like, no, FHIR is the national implementation guide for both of these countries. But
we have to close it here. So please find Sidharth after this. And do
yeah,
check
and again, like if you're interested and want to just continue this discussion and the conversation, tomorrow at this time in the Heritage Gallery, bring in all your FHIR folks if you.
Thank you.